Good afternoon, guys. Hope you guys are doing well. This is going to be the intro to our next major unit, which is going to have to deal with exponents and the rules for exponents. This first video is going to be a two-parter, so this is going to take us through this week, and we're going to continue to build over the course of the next week or two. So first of all, we need to talk about what an exponent is. So your notes have been posted to your Teams page. We're going to start with what should hopefully be some review, and then we're going to build on that as we go through. So I'm going to go ahead and share screen here for our notes so we can kind of talk about some of the basics. So if we look here, you guys have your notes. Let's go ahead and stop that and do it again. There we go. Okay. So we have the idea here of exponents. The first thing that's going to be really important for exponents as we go through this entire unit is I want you to think about exponents as an instruction. So I want you to make sure that as we think about them, we think about an exponent as it's telling you to do something. Don't necessarily think about the number or an operation as much as the instruction, because that instruction is going to change based on the situation. Okay, and as we go further through this unit, I think you'll kind of understand what I mean there. We'll talk a little bit of vocabulary here. The big number there, that's considered the base. All right, and then the little number up there, the exponent, we refer to that as the power. So when we start talking about this as an instruction, the power of 5 is an instruction. All right, and you guys should know at this point that this 5 is an instruction to take the base and multiply it by itself that many times. So the instruction is take 3 times 3 times 3 times 3 times 3. So we're going to take that base and we're going to multiply it out that many times. Okay, so that's what I mean when I refer to it as it being an instruction. Okay, yes, in this case, we're multiplying, but the 5 is an instruction about how many times we're supposed to multiply. And we can evaluate that and we can get our final answer if we want it. Okay, so let's talk then about exponential form. Exponential form talks about writing a number using exponents. And so if we look at this here, 7 times 7 times 7 times 7. Now we can multiply that out, but if it says write in exponential form, we're going to take, because it's the same base, multiplied by itself 4 times. In exponential form, this is going to be 7 to the 4th power. The same base multiplied 4 times. Now this one here, I have the 8s multiplied, then a series of x's, then a series of y's. So this is a common base. So that is 8 to the 4th power times x to the 1, 2, 3, 4, 5th power times y to the 2nd power. You'll notice when dealing with exponents and variables, or variables and what we call the number in front of coefficient, when we have them all touching, that means multiplication. We can separate them with the dot, or we can just have them all multiplied together. Okay, and then remember, parentheses touching parentheses also means multiple. Okay, so exponential form here. The next idea, before we get into the real heavy-duty stuff, is what happens when we have exponents with negative numbers. So -3 to the 4th power and -3 to the 4th power. I want you to just think for a moment and think about what the answers for each one of those are, at least what you believe the answers are, and then we'll talk about it. So for this first one here, the 4 is on the outside of the parentheses. That means that exponent of 4 belongs to everything inside the parentheses. So it means this, -3 times -3 times -3 times -3. So you'll notice that the 3 and the negative are being multiplied 4 times. Well, if we go back to our integer rules at the very beginning of the year, if I'm multiplying with 4 negatives, that's going to make this answer positive. All right, we don't have to show it, but I'm going to put it there right now for argument's sake. And then 3 times 3 times 3 times 3 times 3 is going to make that positive 81. For this second example, this 4 only belongs to the 3. It does not belong to the negative because it's not in parentheses. This negative sign is going to basically sit and wait for whatever happens to this exponent. So this is 3 times 3 times 3 times 3, not including the negative, and then the negative waits. So this answer is going to become negative 81 because of the way in which it's written. Using the parentheses, it means that the negative sign is part of that instruction of the exponent. And when I don't use the parentheses, it is not part of the instruction. Okay, so take a moment right now, and I want you to consider what is the answer to this problem. And then I want you to tell me what is the answer to this problem. So we've got 2 examples here, one with parentheses, one without. Now that we're done with the discussion about those 2 problems, let's go ahead and really get into the nitty-gritty. All right. Multiplying monomials. A monomial means one term. So these are going to be algebraic expressions that are simply one term, and we're going to be multiplying them. And we're going to have a series of exponent rules. The first is something that we refer to as the product of powers. Now, you don't have to really know or concern yourself too much with what we call them, as much as what it is that we do. Product of powers is going to be multiplying with the same base. Anytime we multiply with the same base, we keep that base and we add the exponents. And that's because the instruction of the exponent essentially grows. So the generic rule, and we're going to have this for each one of our definitions, says x to the a power times x to the b power. So here is our common base. So that's what we're doing here. We're multiplying with the same base. And then it tells us to add the exponents. So this is going to be x to the a plus b. We don't know what a and b are, but whatever they are, we're going to add them. Okay, that's the definition, and that's going to be sort of that generic example that proves or shows our definition. So let's look at this here. 5 to the 8th power times 5 to the 7th power. Remember, keep the base. It is very tempting to see multiplication and tell me that it's going to be 25. All right, but this is going to keep the base, so it's going to be 5 to the 8 plus 7th power, which is going to equal 5 to the 15th power. Keep the base, add the exponents. And the question is why? Well, let's talk about why. 5 to the 8th power means I have the base of 5 multiplied 8 times. One, two, three, 4, 5, 6, 7, 8. And then 5 to the 7th power means I'm going to multiply 5 7 more times. 1, 2, 3, 4, 5, 6, 7. So what I want you to notice is when I expand those out, I now have the same base being multiplied by itself 15 times. And that 15 is the 8 and then 7 more. And that's why we add the exponents, but the base does not change because the exponent was an instruction about how many times I multiply that base. Okay. So let's take a look at an example here where I'm showing multiplication using the dot instead of the parentheses. So find that answer. All right, same base, 3 to the 4 plus 6 equals 3 to the 10th power. Now I'm showing this in between step here of the 4 plus 6 because of what's going to happen next. What if I have a problem like this with a negative exponent? Now we're going to talk a lot more about negative exponents next week. But what I want you to look at with this is the rule of what do I do when they have the same base? I add the exponents. So this is going to become 7 to the negative 8 plus 5. And we have to now use our integers from way back at the beginning of the year. If I have a negative 8 and a positive 5, that's going to leave me with 7 to the negative third power. Now that negative third power has additional meaning, which we will explore later. But what I want you to really focus on is that rule of what do I do with the exponents if we have the same base. Now, what if I have something that's a little bit more advanced than even that? So let's go ahead here and look at this. 3, x to the 5th, y to the 7th, parentheses 4, x, y to the 3rd. So this is going to be a more intense problem of multiplication. The coefficients in front multiply independent of any exponent rules because they're just plain old numbers. So that becomes simply 3 times 4. And 3 times 4 is 12. So the number in front is 12. Well, now I'm going to look at the x's, and I have x to the 5th times x. If my x doesn't have an exponent, I know that there is a 1 there. So if I look at the x to the 5th and x to the 1st, they have the same base. So that becomes x to the 6th power. And now I'm going to take the y's, and they're going to multiply. Y to the 7th times y to the 3rd. Notice I am taking each piece that is common and multiplying them on their own. If you think back to commutative property way back at the beginning of the year, I can multiply those pieces and they don't have to necessarily be in quote unquote in order. Well, y to the 7th and y to the 3rd is y to the 10th. So we take the coefficients in front and simply multiply, and then we use our exponent rules to do the rest. So go ahead and try this example on your own. Negative 4 x squared y times 5 x to the 3rd y to the 3rd. So I want you to multiply those. Remember the coefficients in front and then the terms with the same base. All right, our answer for this one here, we're going to take the coefficients in front. Negative 4 times 5 is negative 20. X squared and x to the 3rd have the same base, so I add the exponents and get x to the 5th. Y to the 1st and y to the 3rd have the same base, so those make y to the 4th. All right. So that is the first section for our exponent rules, which is what happens when we're multiplying with the same base. We're going to be going over actually to 8th grade IXL for these sections because they actually fit better than the high school algebra ones do. So this particular section is going to be 8BB, so 8BB number 6. So it's 8BB number 6. And then we'll continue now for part 2 of this lesson, which is going to be the next phase for our exponent rules. All right, and that's going to be, and this is part 2, power of powers. And this is going to have 2 sections to it. Power of powers means we have an exponent inside and an exponent outside of the parentheses. Whenever you see that, you will multiply those exponents, and that's going to be because the instruction increases. So if we're talking about power of powers, x to the a raised to the b power. So here's the exponent inside, here's the exponent outside. The base stays the same, but the exponents multiply by each other. So remember, in part one, we added them, but now if I have an exponent inside and outside, I will multiply. So if we look at this example here, 3 to the 4th raised even further to the 3rd. So this is going to become, the base stays the same. I multiply the two exponents, 4 times 3, so that equals 3 to the 12th power. So all we're doing is we're taking those exponents and we're multiplying. Let's look at an example here. Let's try 5 to the 2nd raised to the, let's call it 7th. Exponent inside, exponent outside. So that becomes 5 to the 14th power. Let's see what you can do with this one. 2 to the 4th raised to the 5th raised to the 3rd. Let's add another layer. Rule is still the same. The base does not change. The base is a 2. Multiply all three exponents. 4 times 5 is 20, times 3 is to the 60th power. Now your integer rules are still going to come into play even with your exponents. So I can do two other things that would bring back some previous rules. So what if I have 4 to the 3rd power raised to the 0 power? We'll talk about what we do with the 0 power later, but right now we would simply take those exponents and multiply and get 4 to the 0 power. And if I have negative exponents, that's also going to come into play. 4 to the negative 2nd raised to the 3rd. Multiply the exponents. Well, what happens when you multiply a negative 2 times 3? That becomes 4 to the negative 6th power. So exponents inside and outside, you simply multiply those exponents with each other. Which brings us to the last piece to this particular video, which is going to be what happens if I sort of mix both of those ideas. If I have multiple bases with an exponent outside parentheses, I will multiply that outside exponent to all of the inside. So it gets sent in, kind of like distribution. And we're going to apply it to every exponent that is on the inside. Okay, so we have two examples here. This 3 on the outside is going to apply to the 5 and x to the 4th. Well, the 5 has an exponent of 1, so this becomes 5 to the 3rd power. And the x to the 4th and the 3 that's on the outside makes that x to the 12th power. Remember, exponents inside and outside, we multiply, but I have to remember that this 3 is also going to go to the big 5 because it's in the parenthesis. So I'll now do 5 to the 3rd power. So 5 times 5 times 5 is 125, x to the 12th power. And then this one here, this 4 is going to apply to the 2, the 3, and the 7. And remember, exponents inside and outside. So this becomes x to the 8th, y to the 12th, z to the 28th. Exponents outside apply to everything inside. Now let's do a combo. Let's bring both sets of rules together. So let's go 3 x squared y, all raised to the, and we'll keep it relatively small, 2nd power. And then another parenthesis, which is going to be 2 x to the 3rd, y to the 3rd, raised to the 3rd power. Each one of these sets of parentheses has an exponent on the outside, so we have to do that first. We still have to keep track of our PEMDAS. So this 2 is going to get sent into the 3, the 2, and the y to the first. So this becomes 3 squared, x to the, remember multiply, 2 times 2 is 4, and then y to the second. I'm going to put a dot in between because these parentheses mean multiply, and now this 3 is going to get sent in here. So that's going to become 2 to the third, x to the, remember multiply exponents, 3 times 3 is 9, y to the 9th. That is getting rid of the exponent on the outside and sending it in. Now let's clean things up. This becomes 9, x to the fourth, y to the second, times 2 times 2 times 2 is 8, x to the 9th, y to the 9th. And now let's go back to part 1 of this entire lesson. I have to multiply, and I have things with the same base, and I have coefficients in front. So let's take the 9 times the 8 that's in front and get 72. Let's take the x to the fourth and the x to the 9th. Remember, same base, add exponents. So x to the 13th power. And then I have the y to the second, y to the 9th, same base, add the exponents, y to the 11th power. So that's going to be pretty much the most intense kind of problem we're going to have from this portion of exponents. Just like part 1, this is going to come from 8th grade. So this is going to be 8th grade, the letter BB, double B's, number 9. All right, and that's going to give you the second batch of exponent rules. Definitely might want to go back and look through this. There's a lot of little details that you want to keep track of, and definitely want to have this in your notes. We'll build on these notes again next week as we add exponents that are negative as well as powers of 0. And then what do we do when this stuff is all in fractions? Right, hope this is helpful for you guys. And remember, we've got work days the next 2 days. Talk to you guys later, and I'll see you tomorrow.